This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Topic 5 of Week 4. Multiple pumps, series and parallel. When one pump can't do the job, you stack two. The whole topic rests on one pair of rules. Series adds heads at the same flow, parallel adds flows at the same head. Get those straight and you build the combined curve and find the new operating point. Get them backwards, the single most common error here, and your answer lands nowhere near reality. Why stack pumps? A single pump's curve may not reach the duty point, and it can fall short in two ways. Need more head? A tall lift or long line? Put the pumps in series. The discharge of one feeds the suction of the next, and heads stack. Need more flow at the same lift? Put them in parallel. Both draw from the same source into the same header, and flows stack. Either way, the recipe is the same. Build one combined pump curve, then intersect it with the unchanged system curve. And that's key. The system curve doesn't change when you add a pump. You're only changing the supply side. Series first. Pumps in series share the same flow. Every gallon through the first also goes through the second. So at any flow, their heads add. Pick a flow, read each pump's head there, and add them. For two identical pumps, the combined curve is the single pump curve with every head doubled. Twice the shutoff head, same runout flow. Series buys you head, not flow. The first pump raises the fluid's energy. The second raises it again from there. Now, parallel. Pumps in parallel share the same head. Both lift against the same header, so at any head, their flows add. Pick a head, read each pump's flow there, and add them. For two identical pumps, the combined curve is the single pump curve with every flow doubled. Twice the runout flow, same shutoff head. Parallel buys you flow, not head. Note the symmetry. Series adds heads vertically at fixed flow. Parallel adds flows horizontally at fixed head. The comparison table. The one thing you must not invert. Series head adds, flow held common, sum vertically. Parallel, flow adds, head held common, sum horizontally. For two identical pumps, series doubles shutoff head, parallel doubles runout flow. Use series for more head, parallel for more flow. Memory hook, series raises head, parallel lets flow. Reproduce those first two rows under pressure, and every multiple pump problem is just bookkeeping. Take one base pump curve and build both from it. Series adds heads, so hold each flow fixed and push the curve up. It sits above the single pump curve everywhere. Parallel adds flows, so hold each head fixed and stretch it right. The figure shows all three: single, series raised, parallel widened, each crossing the system curve at its own higher operating point. One caution: because the system curve rises steeply, doubling the pump curve rarely doubles the delivered flow or head. The steep system curve eats much of the gain. Worked problem. The classic head-to-head. Each identical pump follows head equals 100 minus 0.001 times Q squared, head in feet, flow in GPM. The system curve is 20 plus 0.003 times Q squared. We'll compare three ways: one pump, two in series, two in parallel. The plan: for one pump, set pump head equal to system head and solve. For series, double the head and set equal to the system. For parallel, each pump passes half the total flow, so write its head with Q over 2 and set equal. Run the numbers. One pump, set pump head equal to system head. Q squared lands at 20,000, so flow is about 141 GPM at 80 feet. Two in series, double the pump head and set equal to the system. Flow comes to about 190 at 128 feet. Series lifted the operating point high in head and raised flow somewhat, since the system curve keeps climbing. But flow went from 141 to 190, nowhere near doubled. Series targets head. The head nearly doubled, while flow grew only about a third. Now, two in parallel. Each pump passes half the flow, so write its head with Q over 2, set equal to the system, and total flow comes to about 157 at 94 feet. The comparison table: one pump, 141, series, 190. Parallel, 157. Here's the real lesson, and it surprises people. On this steep, friction-dominated system, the gains are modest, and series actually wins on flow, because the steep curve lets extra head buy flow. On a flat, static-dominated system, it flips, and parallel dominates. So the winner depends on the shape of the system curve, not a slogan. Always solve the intersection. Never assume parallel means more flow. 4 traps. Number 1, leading. 1. Inverting series and parallel. Series adds head at common flow. Parallel adds flow at common head. Swap them, and your operating point is nowhere near reality. Anchor it. Series raises head. Parallel lets flow. 2. Adding the wrong quantity in parallel. Each pump carries half the total flow, so use Q over 2, and the heads are equal, not added. 3. Assuming 2 pumps double the duty point. The rising system curve means they never do, so always intersect, never scale by 2. 4. Forgetting the system curve is fixed. Adding pumps changes only the pump side, intersected with the same system curve from topic 4. Bookmark the pages. Centrifugal pump characteristics is the home of both rules. Series, heads add at common flow for more head. Parallel, flows add at common head, each pump carrying half the total flow for more flow. Building the curve, series stacks up and parallel stretches right. The new operating point is the intersection of the combined pump curve with the same system curve, H static plus KQ squared. And keep the reality check. Gains are always less than double, because the rising system curve eats much of the benefit. Nothing new appears on the system side, only the pump curve changes. That wraps the pump curve thread for week 4. You can take any pump curve, build its series or parallel combination. Series adds head at common flow, parallel adds flow at common head, and intersect with the system curve for the new operating point. With topic 4's single pump point and the affinity laws, you own the core of pump selection. The move is the same every time. Identify the curves, combine on the correct axis, intersect, read the duty point.
The full study guide, with every equation and common exam trap, is free at peprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.